In this video, we're going to continue to learn about vectors, adding, subtracting vectors in 2 dimensions. And the first thing we're going to learn is how to communicate in writing or with words the direction and magnitude of vectors. So there are 2 ways to specify a vector, and the first way we're going to learn is polar coordinates. Before, when we learned about vectors, specifying direction was fairly simple. We could just use a word like east. Vector v1 is 2 meters east. It points east. But now it's a little bit more complicated. You can see that this vector is not pointing north or west, but somewhere in between. Imagine we are initially pointing towards the north, and someone is going to tell us to turn to point in the same direction as V2. So since we are initially pointing north, we'll say of north, and we are going to turn 30 degrees. And in which direction? You could either turn towards the east or you could turn towards the west. And in this case, we want to turn 30 degrees towards the west of north. Sometimes I think maybe a better preposition would be from, right? Because turn towards the west, starting from the north. That's how we specify the direction. So this vector, V2, is 10 meters, 30 degrees west of north. Now, this angle also has a complement, and the complement to 30 degrees is 60 degrees. So how could we use 60 degrees in this vector specification? Well, turn 60 degrees from where? From the west, right? So the second letter is west. And turn which way? Turn towards the north. 60 degrees north of west. Okay, give the video a pause and try question 1 here. And when you're done, go to the OneNote and take a look at the answers. Specifying a direction in terms of a magnitude and an angle relative to one of the cardinal directions is called polar coordinates. Another method is to use components. In a previous lesson, I gave you this exercise where you were to draw the vector sums of these vectors that I had given you. And when I made the video on this, I said, make sure you draw vector A exactly as I have done, same length and direction. And to do that, I suggested counting the squares. You must travel 4 squares in the east direction, and you must move 3 squares in the north direction. And if you gave someone those 2 values, they could reproduce this vector A. This is what we mean by components. So that's what we're going to do with these vectors. We're going to find the east and north components, right? And let's, as an example, let's take a look at this vector that we have just seen previously. We specified this vector in terms of polar coordinates, 10 meters, 30 degrees west of north. Let us find the components of this vector which point in the east direction and in the north direction. Okay, you could draw them there, or if you like, you could draw them over here. Doesn't matter. Okay, so how are we going to do that? Well, notice we have a right angle triangle here, and that's how we're going to solve this. You may recall from your math class last year working with right angle triangles and learning about the 3 trigonometry ratios. Sine of the angle equals the opposite side divided by the hypotenuse. cosine of the angle equals the adjacent side divided by the hypotenuse, and tangent of the angle equals the opposite side divided by the adjacent side. And you may recall this useful mnemonic, so, ka, toa, right? Sine equals opposite divided by hypotenuse. Cosine of the angle is the adjacent side divided by the hypotenuse. Tangent of the angle, the opposite divided by the adjacent. So let's take a look at this triangle, and let's find the north and east components of this vector, which is 10 meters in length. Okay, so to do that, okay, I've got the hypotenuse here. I want the opposite side and the adjacent side. That's what I need to find, right? The opposite side is V2 east, and the adjacent side is V2 north. So let's start with V2 east, okay? Now, some of you might be saying, oh, look, it points west. Why are you saying east? Well, remember that the word east just defines the positive direction along an axis, and then the opposite direction, which happens to be west, is just the negative. We'll use the negative sign to indicate that direction, okay? And since convention holds that we often use east and north as our positive directions, that is why we are finding the east component of V2. It will be a negative number. Okay, so this is the opposite side of the triangle relative to our angle. And so when we think about our trig ratios, which one uses opposite and hypotenuse? Sine does, right? Sine is opposite over hypotenuse. So I can write now the sine of the angle equals the opposite side, the thing I'm interested in solving for, V2 east, divided by 10 meters, the hypotenuse, okay? All right. Okay, I'm just finding the absolute value right now. I'm going to get a positive number, but recognize that since it actually points west, it's going to be negative. Okay, so we could solve this for V2 east, right? Multiply by 10 meters, cancel, and we will get V2 east equals 10 meters times the sine of 30 degrees, which equals 5 meters. And since this points in the negative direction, V2 east equals negative 5 meters. Let's find the north component of this vector. This time we have the adjacent side, the adjacent side and the hypotenuse. So we are going to use the cosine of the angle. Cosine equals adjacent divided by hypotenuse. And let's write that down here. So we have cosine of 30 degrees equals V2 north divided by 10 meters. I'm going to just move this out of the way here. And we could solve for V2 north like this. And we'll get, cancel. We'll get V2 north equals 10 meters times the cosine of 30 degrees, which equals 8.66 meters. So now we have the components of vector v2, right? Vector v2 equals, right, vector v2 east plus v2 north, right? You could see this vector sum, and we know the values of v2 east. v2 east equals negative 5 meters. v2 north equals 8.66 meters. Sometimes you'll see the vector written like this: v2 bracket negative 5 meters comma 8.66 meters, right? And you may be used to graphing points on the Cartesian plane, right? This is the coordinates of the head of vector v2. Okay, pause the video and go ahead and find the sides of these triangles. That is, find the east and north components of these vectors.